In the figure below, O is the center of the circle and RT is tangent to the circle at X. If triangle RST is equilateral, what is the value of RT over YZ? To get the value of this fraction, we need the length of this line segment RT and the length of the line segment YZ. And the question says a triangle RST over here is an equilateral triangle. So all the three sides must be equal in length. Okay, now let me assume A has the length of each side of this equilateral triangle RST. And the question says RT is tangent to the circle at X here. Okay, and we know that OX represents the radius of the circle. At the point of tangency, always the angle between the radius and tangent is right angle. So here we have right angle. And we know that the measure of each interior angle of an equilateral triangle is 60 degrees. So here we have 60 degrees angle measure, and the interior angle over here 60 degrees, and the interior angle over here 60 degrees. Here, Sx is a line segment is drawn from one of the vertices S to the side RT of this triangle. And also, the line segment Sx intersects the side RT at the right angle. So, Sx is the altitude of this triangle. Since RST is an equilateral triangle, this altitude Sx will bisect this side RT. That is, will divide the length of RT into two equal parts. Then the length of this line segment XT and the length of this line segment Rx is half of this A. That is the length of XT over here is A over 2, and here also we have A over 2, and also the altitude over here will bisect this interior angle 60 degrees. That is, it will divide this angle into two parts. So here we have 30 degrees and here we have 30 degrees. Now let's consider the right triangle XTS over here. It is a 30, 60, 90 special right triangle. And in this 30, 60, 90 special right triangle, the side which is opposite to the smallest interior angle 30 degrees is considered as the shortest leg. So XT is the shortest leg of this triangle. The next longer leg is the side which is opposite to 60-degree interior angle. Now, to get the length of this side of the triangle, which is opposite to 60 degrees, we have to multiply the length of the shortest leg by square root of 3. So, when I multiply this one by square root of 3, I am getting A over 2 times square root of 3. And here, OX is the radius and OS is also the radius, and this SX is the diameter. We know the length of the diameter, that is A times square root of 3 over 2. Now, to get the length of this radius OS, we have to divide the diameter by 2. When I divide this one by 2, I am getting A over 4 times square root of 3. And let's consider the triangle OSZ over here. In this triangle, the length of OS and the length of OZ are equal because both of them are radii of the circle. Since the length of OS, that is the radius of the circle is A times square root of 3 over 4, the length of this OZ also the same thing, that is A over 4 times square root of 3. And OSZ is an isosceles triangle because two sides are equal in length. In an isosceles triangle, the interior angles which are opposite to the sides of equal length must be equal in measure. So this interior angle and this interior angle, both of them are opposite to the sides of equal length. So they must be equal in measure. Here we have 30-degree interior angle. Here also we have the same interior angle 30 degrees. Then what is the measure of this interior angle? It has to be 120 degrees because in any triangle the three interior angles will add up to 180 degrees. Okay, now let's consider the angle measure over here. It's a straight angle. It measures 180 degrees. The measure of this part is 120 degrees. Then what is the measure of this part? It has to be 60 degrees. Okay, here we'll have right angle. So because in a triangle, the three interior angles will add up to 180 degrees. Okay, now let's consider the special right triangle over here, 30, 60, 90 special right triangle. In this 30, 60, 90 special right triangle, this is the shortest leg because it is opposite to the smallest interior angle, 30 degrees. We can assume X as the length of the shortest leg. Now, let's consider this leg over here, which is opposite to 60 degrees. To get the length of this leg, we have to multiply the length of the shortest leg by square root of 3. Then x times square root of 3 is the length of xz. And this is the hypotenuse of the triangle because it is opposite to the right angle. Now, to get the length of the hypotenuse, we have to multiply the length of the shortest leg by 2. Then we get 2x as the length of OZ. But already we have the length of OZ, that is a times square root of 3 over 4. So this 2x and this one, both of them represent the same stuff, that is the length of OZ. We can equate them, that is 2x equals to a times square root of 3 divided by 4. Okay, now let's multiply both sides of the equation by 1 over 2. Then this 2 will cancel out. I got x on the left side. On the right side, a times square root of 3 divided by 4 times 2 is 8. Okay, now let's get the length of this line segment, that is given by x times square root of 3. For that, we have to multiply both sides of this equation by square root of 3. Then we get x times square root of 3 equals to a times square root of 3 over 8 times square root of 3. Okay, x times square root of 3 equals to square root of 3 times square root of 3 is just 3. Then we get 3a over 8. Here, I got the length of this line segment, that is 3a over 8. Now, let's consider the line segment YZ over here and the line segment RT over here. Both of them are perpendicular to the same line segment. So, we can consider RT and YZ as parallel. Actually, YZ is the line segment we have instead of the equilateral triangle RST, and this line segment YZ is parallel to the side RT of the triangle. Already we know that SX, the vertical line segment, bisects the line segment RT over here. So the same line segment SX will bisect this line segment YZ as well. So whatever length we have for this part, the same length we'll have for this part as well. That is x times square root of 3. Now let's get the length of this line segment YZ. That is YZ equals to x times square root of 3, positive x times square root of 3. YZ equals to, when I combine these two terms, I am getting 2 times x square root of 3. YZ equals to 2 times, already we have value for this x times square root of 3, that is 3a over 8. We can plug in, then we get 2 times 3a over 8. Here 2 goes into 2 1 times and 2 goes into 8 4 times. I am getting YZ equals to 3a over 4. Now we have the length of our RT and also YZ. Okay, let's get the value of this ratio, that is RT over YZ equals to, the length of RT is A, that is the length of each side of the equilateral triangle divided by, and the length of YZ is 3A over 4. Okay, now let's do some simplification, that is A. We can change this division as multiplication and take reciprocal for this one. Then I'm getting 4 over 3A. This A will cancel out. I'm getting 4 over 3. Here I got the value of RT over YZ, that is 4 over 3.